So now that you've practiced finding equations of parallel and perpendicular lines, question 5 asks you to go through and it gives you the equations of two lines. So here's each 2, 2, 2 all the way down. And it wants you to decide if they're parallel, if they're perpendicular, or they're neither. So just really fast to remind you, parallel lines have the same slope, but they have different y-intercepts. Perpendicular lines have slopes that are opposite, reciprocals. So this one goes with parallel, this one goes with perpendicular. Perpendicular lines don't have a rule about the y-intercepts. Two lines can be perpendicular and have the same y-intercept, or they could be perpendicular and have different y-intercepts. And then if it's neither, it means that it's not this and it's not this. So neither would be if it had the same slope but the same y-intercept. Neither would be if the slopes were opposite but not reciprocals, or they were reciprocals but not opposites. And so when you're answering these questions, you're going to be looking at the slopes on all of them. Remember that the slope is the number in front of the x. And so when I'm doing these, I'm going to go through and highlight. So on the first one, I'm looking at the 1/2 and the 2. On the second one, I'm looking at the 7 and the 7. On the third one, I'm looking at the -3 and the positive 1/3. Here, the number in front of the x is the number 1. So it's the number in front of the x. And here, the number in front of the x is the number 1. Here, I'm looking at 5 and -1/5. And then on this last one, on F, I'm looking at the number out front right here, which is a positive 1, and the number that's out front right there, which is a -1. So you're being asked to select the correct answer for each one of these. So in the first one, you have a 1/2 and you have a 2. 1/2, 1/2, and then positive 2 for this one. So this one and this one are flips from each other because you flip the 1/2 upside down and you get the 2. But to be perpendicular, they have to be opposite and reciprocals. So for this first question, we would say that it's neither. If the question asks you to explain why, you would say that they are reciprocals, but they're not opposites. And so a lot of students, when they're learning about perpendicular for the first time, might think that this first one is perpendicular, but it's not. On the next one, this one's a 7, this one's a 7. The y-intercept on this one is +3. The y-intercept on this one is 0, so they don't write +0, it's just 0. And so that means that these lines are parallel to each other. They have the same slope, and they have different y-intercepts. On the next one, this slope is -3. This slope is positive, so they're opposites. And the 1/3, if you flipped the 3 upside down, it would turn it into a fraction, so it would be 1/3. So these are perpendicular because the slopes are opposite reciprocals. And again, for perpendicular lines, the y-intercept doesn't matter. Let's see, +1 and +1 for the slope, so the slopes are the same. +8 and -9 for the y-intercept, so the y-intercepts are different, so that means it's parallel. Same slope and different y-intercept. And then for this one, you've got +5 and +1/5, so it's neither, not perpendicular, because on this one, they're reciprocals but not opposites. And then the last one's probably the trickiest one, because on the final one, it says, so the number in front of this x is a +1, and the number in front of this x is a -1. So they are opposites. If you flip a 1 upside down, it stays 1. So on this last example, they are perpendicular with each other because the slopes are opposite reciprocals. Even though it doesn't look like they flipped upside down, they in fact did. So that's just an example of looking at the slopes to help decide whether the lines are perpendicular, parallel, or whether they're neither. In example number 6, it says, use the figure to the right to answer the following questions. So, okay, so this question's a little bit complicated. If you have two lines that are on the picture, so we're being asked about the slope of these two lines. So this line over here, we can figure out what its slope is. So the one that's going up is going to have a positive slope. So we have to find 2 points that are on the line. So I think this point's on the line, and then I think this point's on the line. So to get from here to here, it goes up 1, 2, 3, 4, and then it goes to the right 1, 2, 3, 4, 5. So the slope of this line would be 4 over 5. And then this line's going down, so this line's going to have a negative slope. And if I find 2 points that are on the line right here, it looks like the slope of this line is you go down 1, 2, 3, 4, and then you go 1 to the right. So it's the slope on this one is, 3 to the right, 1 to the right. Down 1, 2, 3, 4, and over 1. So the slope on this one is going to be negative 4. You could write it as negative 4 over 1, but that would just reduce to negative 4. So these are all situational questions. So the first one says, a line with a positive slope is parallel to one of these lines shown, and they want you to figure out what would be the slope of that line. Well, this line has a positive slope, and this line has a negative slope. So if a line with a positive slope was going to be parallel to one of these, it could only be parallel to this one, because in order to be parallel to this one, it would have to have a negative slope. So if it has to be parallel to this line, they want us to answer the question, what's the slope? So the other line would have to have a slope that was the same as this one in order for them to be parallel. So the slope of the new line would have to be the same as the other one. All of these questions go through and describe different situations. Make sure that you're being careful to find the words parallel, perpendicular, perpendicular, parallel, because that'll change your answer to the question. In the next one, it says a line with a negative slope is perpendicular to one of these. So you have to remember that perpendicular means that you're flipping the slope and you're making it be the opposite sign. So in order for it to be perpendicular to one of these and for it to be negative, it would have to be perpendicular to this same line that I started with, because this one, when I flip it, and then when I make it opposite, it would turn negative. On this one, when I flip it and make it opposite, it would turn positive, but it says that the line has to have a negative slope. So if a line was going to be perpendicular to this line, I would flip the 5 over 4 upside down, and then I would change it to be negative. So it would be negative 5 over 4 would be the slope for a line that would have to have a negative slope if it was perpendicular to one of those two lines. The next question says, these kind of feel like puzzles, to me anyways. The next one says, a line with a positive slope is perpendicular to one of these lines shown. So if I was going to flip it and make it be the opposite sign, and if it was going to end up being positive, that would mean that I had to start with a negative number. So if I flipped this upside down, it would turn into 1 over 4, and then if I changed it from negative to positive, it would be positive 1 over 4. So for a line to be positive and perpendicular to one of these lines shown, it would have to be this line it was perpendicular to, so you'd get 1 over 4. And then the last one says, if the line has a negative slope and if it's parallel to one of these lines. So the only one it can be parallel to and still be negative is this one, because in order to be parallel to this one, we already said it would have to be positive. So for this one, my slope would be negative 4, or negative 4 over 1. You can write it either way. But in order for it to be parallel to this one and be negative at the same time, this is the only line it could be parallel to. Make a note underneath the picture that says these lines are not perpendicular. In order for them to be perpendicular, they would have to be the flip of each other. So if this one was 4 over 5, this one would have to be negative 5 over 4. If this one was negative 4, this one would have to be positive 1 over 4. And so you can tell right here by looking at where they intersect with each other that this right here is not 90 degrees. And so because it looks like it's so not 90 degrees, you can use that to help you determine the answer to that question, okay? All right, so in example number 7, which is the last example for this second page of notes, it says the endpoints of a side of a rectangle ABCD in a coordinate plane are A is at 1, 5 and B is at 3, 1. So they want you to find the equation of the line that contains the given segment. This is definitely a challenging question. We're going to go through and we're going to solve this one together. But there's not, you don't have a piece of graph paper shown on your pages. And so I'm going to grab out a piece of graph paper so that we can graph these just to give you a little bit of a visual. You can draw a small sketch for this over here on the side, or if you would prefer, I have graph paper in the little wire basket over on the side of the classroom. So you can always grab yourself a piece of graph paper and write that down. So that's what I'm going to do right now. BRB. So you guys, drawing a little sketch of a graph for this one is going to help you understand it so much better than if you just go into it blindly. They say that you have a rectangle. So in a rectangle, all 4 angles are 90 degrees. All 4 sides are parallel to the pair of sides that's opposite it. And then the 2 sides that are opposite each other are congruent, and the 2 sides that are opposite each other are congruent. So they tell me for this question that I'm working, well, I kind of missed that there, but that's okay. So in a coordinate plane, they tell me that one of the points is at 1, 5. So that's point A. And then they tell me that one of the points is at 3, 1. So this is point B. And so they want me to find the equation of the line that contains the given segment. So in order to find the equation of the line that contains the given segment, I'm going to have to do something with the slope of the line, and then I'm going to have to do something with the y-intercept of the line. So from A to B, it goes right here. So this is one of the sides of my rectangle, and so I can use the information given to me to find the equation of that line. Right now, for AB, I know that it goes through the point 1, 5, and I know it goes through the point 3, 1. So those are 2 things that I know about the picture. So knowing that the line goes through those 2 points, I can find the equation of that line. To find the equation of the line, I'm going to need to know y equals mx plus b, but I would also need to find the slope of the line in order to find the equation of this line right here. So I'm going to start by saying that I know that point A is at 1, 5, and I know that point B is at 3, 1. So before I can BMXY it, I need to figure out what the slope is. If you graph it, you can just count the slope. You go down 4 and 2 to the right, so your slope is going to be down 4 over 2, so down 2 over 1. So my slope should be -2. But without the graph on your paper, you can't solve it that way. So I would start by using the slope formula to figure out what the slope of this line is. So my slope for this one is going to be, let's see, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to get -4 divided by 2. So I would get that my slope of this line is -2, same as I got from the graph. And so once I know that the slope of the line is -2, now I can make my BMXY chart, which I'll do up here. So I'm not doing parallel or perpendicular right now. I'm just using what we learned about back when we did equations, and I'm finding the equation of the line. So if my slope is -2, remember I can pick either one of these points to plug in for the x and the y, so I'm just going to pick the first one, but it doesn't matter. If you pick the second one, you'll get the same answer. And so when I do y equals mx plus b, I'm going to put the y in for the y, I'm going to put the m in for the m, the x in for the x, and the b goes for b, because that's what I'm trying to find. And I get that my b is 7. So if I was trying to find the equation of this line, and if I kept it going, I would go, let's see, I went down 2 over 1, down 2 over 1. So to go backwards, I would go up 2 over 1. And so this point right here would be the point where the graph crosses the y-axis, up at 1, 2, 3, 4, 5, 6, 7. So that would be the equation of this line. So my answer for letter A is y equals -2x plus 7. That's the equation of the line that contains the segment AB. That's one of the sides on my rectangle. So this right here, -2x plus 7, is the equation of the line that if I kept this going and kept this going, side AB would be a part of it. And so you can draw that in on your pages by using either an ID card, you can use a ruler. So if you kept this side going, I'm going to draw it a little bit lighter on my paper. So 7 is right here where it would cross the y-axis. So this point right here would be your y-intercept, and the equation of this line would be y equals -2x plus 7. So the next thing they want us to do is they want us to find the equation of the line that would contain side BC. Now for point C, they don't tell you whether the rectangle goes this way or whether the rectangle goes this way, but whether it goes this way or whether it goes this way, it's going to be along the same line, so it doesn't matter which way you go. Just make sure you notice that for side BC, one of the points it goes through is going to be this point right here. Rectangles form 90-degree angles with the pairs of sides that intersect each other. So because of that, I know that side BC is going to be perpendicular to side AB, the one I already found. So I don't have a second point to find a slope with for this one, but I don't need to. The slope of this line was -2. So when I do my BMXY chart on this one, I'm going to flip the -2 upside down, so it's going to turn into 1/2, and then it was negative, so it'll change to positive. So when I make my BMXY chart here, BMXY, I know that this line is going to be perpendicular to the last one, so I'm going to use +1/2 as my slope. And then I know that side BC goes through the point 3, 1. So I'm going to use 3, 1 for my x and for my y for this one. It goes through the point 3, 1. So y equals mx plus b. Y equals mx plus b. You could turn this into a decimal and then just handle the decimal if you'd like to, but I'm going to continue to do it the same way I did on the last question. So I'll times this one by 2, I'll times this one by 2, and I'll times this one by 2. The 2's here are going to cross out. So I'm going to get 2 equals 3 plus 2b. And then when I divide both sides by 2, I'm going to get that b is equal to -1/2. So my equation for the line that contains side BC is going to be y equals, my slope is 1/2, and then my y-intercept is -1/2. This line is a little bit harder to graph on the original graph because the y-intercept is a fraction, but I can come over here and show you where it would be. So again, whether I make the side of the rectangle come out this way or I make the side of the rectangle come down this way, it goes through the point 3, 1, and then my slope for this one is +1/2. So my slope is going up 1/2. So I'm going to go over 2, down 1, so that would be a point on the graph, and then I'm going to go over 2, down 1, so that would be a point on the graph. And I can also go this way if I wanted to extend the line this way. So this is the line that would contain, whether the rectangle went to the right or whether the rectangle went to the left, this is where the second side of the rectangle would go. This angle right here, depending on which side you drew it on, would be 90 degrees because we proved that they were perpendicular based on the slopes. And the equation from this line would be the y-intercept is at -1/2, and it goes up 1/2, up 1/2 from that point. So you guys definitely, it's definitely a complicated question, but you have the skills and the know-how to figure out how to do it. It's just a matter of making sure that you follow the steps. So if there's one like this tonight in your homework, just make sure you use this as a clear example to help you do that.